conference.
So how many minutes online at Lampu is needed? So probably you have to do your own one. Ask you that distribution. I think those that are using handphone one, you have problem using this one. And then we try to delay the first original differentiation to create a delay here, so that delay will introduce to other items accordingly. And based on that, we try to cancel some terms by doing the first one minus second one to produce a different equations, a new different equation. Where in this way that you can see that you start to introduce a recursive item into the different equation, but at the same time actually reduce some other terms, input terms. That is therefore you want to create out the different equation, then you are able to get a transfer function. Okay, so that's also one of the way that we can actually produce the recursive solutions. Okay, so it's the same one that I'm going to talk about later is in the slide. So I just make use of the example over here. So therefore, you can actually sort out this one in order to obtain this one. So now based on this one, based on what you have from the transfer function here, then you try to draw your zeros and poles on the Z plane. And then based on this one, then you try to determine your stability. So this is the sum of the work that I think you need to do factorization. Okay. So in this case, you have to do some factorization on this one. I think you need to make the Z in terms of positive power first. Okay. So from here, actually, you can actually try to figure out whether it's stable or unstable. So this is the solution over here. Okay. So whereby you have to do some factorization, then you may see that your zeros actually across this on the axis, y-axis and z-axis, but each of the on the unit circle, each of the zero on the unit circle. Whereas you have you have one pole over here, because factorization will give you a z equals to one pole at here, and then you have other poles, 3 poles at the origin. Because there's one pole on the unit circle, so therefore it's marginally stable. So this is some comments that is. So obviously this one you have to do your hand drawing. In this case, I provide the solution I provided over here. I use a MATLAB to provide the answers. Okay. Then I think the next one is about the impulse response. So you download the questions, and the next question actually is asking for the calculate the first six values of the impulse response by long division, and then you identify whether from here whether this is a so-called your FIR or IR filter. Okay, so when you do a division, you may notice that actually so good that division is on the first time, probably is the first time you see that it's so nicely totally divided, where you have this sort of answers over here. Then in that case, actually you may see that since that you have only these few terms, after that all zero already, so therefore this is the FR filter, but it's a recursive filter. So that's why there's I think last week I mentioned that the recursive filter not necessarily a IIR filter. So this is one of example that a recursive filter, it can be a FR filter. It not necessarily must be an IIR filter. So this is a bit a little bit easy if you do it carefully. But let's say you don't believe, then try to do something else. How come I always got the complete division? So it may happen. It depends. If FR filter, definitely will happen to be the complete divisions. Okay, so that's to talk about number 4. That's the first 6 value. So first 6 value. So if you write over here 1, 2, 3, 4, sorry. So you'll be deducted marks because it asks for first 6, so it will give us 4 only. So you go first 6, then the rest of them obviously is 0 and 0. So obtain your first 6 value. Okay, so any question so far? So you can try out the question again. Let's say you have you don't follow the solution first. Just try to try to solve your own way, and then to test your understanding. Then the next one, it will follow the next question. So we will just look at the next question. The next question is you determine the response, determine the output of a moving average filter. If let's say you have this kind of the input, so you need to know what is the input, so that can be a table to do calculation. Then you still observe the response. From the response, you try to explain the moving average filter, whether why it has a characteristic of a low pass filter. Okay? Based on the result on the xn, as well as the calculation on yn. So that require your calculation. Probably can tabulate it. Then you can get some answers. So these are some of the answers. This will be the answer over here. Your input, then this output. And why we say low pass filter? Because 0 to 1, there's a very sharp transition between 0 to 1 as well as 1 to 0. But that sharp transition, which represents a high frequency component, is smoothened by yn, which is the after moving average. You have an output of 0, 0.25, 0.5, 0.5, 1, it slowly reach to 1. If you imagine a lollipops, then this one very sharply go to 1, but now this slowly go to 1, where represented by after filter, your high frequency become a low frequency components. Where this is another one, 1 to 0, also very sharp, but it's now smoothened slowly going down to 0. So that kind of characteristic, you can see that here input got high frequency component, but after input, after go through moving average, we left only a low frequency component. So there is a low pass filter behavior that will give you a response, something like this. Okay, and obviously from here, actually you move to B. B is to implement your filter. Implement this filter. This one, where is it? Implement this guy into the canonic form. So that's because of the format, it will probably be easy that to obtain these two equations in implementing the canonic form. Okay, so we compare this filter and your original FR filter, then you may see that the delay you still have the same, but I think the main thing is whether the computation over here. Okay, so it save you 2 memory units because of coefficients. Previously, you need to your FR filter need to memorize the 4 coefficients, but now you just need to have the 2 coefficients. Okay, and yeah, I think in this case you have an additional of the delays, because in your FR filter the one got 3 delays only. Now this one got 4 units of the delay, so it means that you need the extra additional of the shift register. Okay, so that's the question that actually on I think it's one of the recent years. So you can actually try it out. So any question? So you can continue doing, but I'm sorry, you are not allowed to submit anymore. So you can compare your results with this one, the solution here, and see which part that you will make mistake, or you don't make mistake, or make it correct. Then you can do so, because the question never say you need to come out with different equations, but you need to state the assumption that you make when you are doing such a graphical way, that changing the direct form to canonic form. Okay, so there's an assumption behind that. Please take note of that. Okay, so that's this is the topics that just now we just went through. So basically, just to try to tell you that recursive filter, non-recursive filter, basically we look at the structure, whether completely or without feedback. And FR and IR not on the structure, is on the impulse response. Okay, so let me see my attendance. Let's see who is not coming, who is coming. Billy, can you take attendance for me? Okay, so I think Leka, I saw Sahira doing the test quiz. However, I don't see her in the attendance now. Then who else? Rao not coming. Who else? Vignesha, am I right? So basically, I got 13 today. Look Ho Wai. And who else? Oh, Jin Kang. Oh, Jin Kang slept so long. Until now, only wake up. I see. Okay, so then, okay, let's, I just want to ask only, because I think yesterday I mentioned to the powers and the students that actually, I know next week you need to submit your thesis, whether on the binding or non-binding, whether electronic, but anyway, you need to do a submission. And then our class Dsp on the 29th, which is a day before, which I think that if let's say I just postpone the class, that will make a maximum benefit for you. So hopefully, if you can persuade Mr. Taif to do the same one, that will be better for you, isn't it? But anyway, I think you should focus on your thesis now. Because until now, we still don't know how your final exam will be conducted. It's very subjective to the MCO also. So we have no idea at all. So let's say it's doing online, then like you practice yourself. So you can ask why 10 minutes, no, but anyway, in the first place, you don't read the instruction. So then you have to blame yourself. But well, at least you will notice this, then later on, hopefully, when you do a real run, if you're doing the real exam, then you are not repeating the same mistake. Okay, so I just probably I can try these features. I never tried these features. Probably I can do a pooling. There's a pool. So let me try this thing. So let's try and see. So I want to know that next week should I postpone the SP class? Okay. So yes means that I should. No means that I should not. So can you vote now? Only 2% agree. Yeah, so little only. I thought I need 2/3, need 2/3. So I need to. No, I don't have. So I got 3/5 only. Yeah. So that's another way that to check attendance in. So now I see only 46%. So I need 75%. Now I got 46% only. So I'm sorry. So still not enough. So those are not answering, probably they are not in front of computer now. Okay. Then Gan, Gogel, John, Jin Kang, Jigen. Yeah, basically today we don't have attendance, full attendance. We got only 14. Okay. So I think Gogil and Jin Kang, I think they are just doing some their own stuff, own street time. Oh, there's a no. Okay, a gun. Okay, why no? Please justify. So I'm not sure others can see the voting result or not. I'm not sure if you can see or not. I can see the result. I can see who is voting, what the response he votes. But anyway, the consequence of postponing is, so let's if I analyze it, so as you know that the 30th that you need to submit your thesis. After that, probably I think the Dr. Shin suggested 8th of May you are going to do an interview, whether face to face or not face to face, I also don't know. But you should prepare a poster for your so-called your presentations. Then on the other hand, after that after 8, then by academic calendar of the Northumbria, then I believe that 12, 11 you cannot do the exam. 12 you have to do the only can do exam because of public holiday. Then starting 12 you are starting to have your exams accordingly. So therefore if you look into it, then basically if let's say next week you postpone the class, then the following week, let's say 6th of May, then I need to conduct class again, and because not much choice left for us only. So because after 6th of May, 8th of May is an interview, 6th of May, after 6th of May, 8th of May, after that 12th of May is a starting exam already. Whether it's online or not online, don't know. But anyway, you will start to do your exam already. So that's why those are the classes that we need to do, then we need to finish it. And as well as I mentioned that I want to do a MATLAB workshop, so I'm not sure. Probably what I can do is I can next week probably it's not necessary for you to come, but I can try to do online, do a pre-recording. Although I do it online, but I just do a pre-recording so that you can actually look at the recorded video to follow. So it's a must that you need to complete the MATLAB workshop, first of all. Secondly, like I think I mentioned it earlier, so who knows that let's say this coming exam is an online exam, there could be a question that asks you to do using software, or who knows, I don't know. So because the package of the syllabus that we have for DSP is basically covering everything, including the workshop, so we cannot claim that hey, this one no. Okay, so I can do so, but I think it's those that you are running, you are exhausting to write the thesis, so it's better that you finish it as soon as possible. Okay, and I think you need to turn it in whatever all these activities are. Okay, so let's move on. So I postpone our next class, but I'm not sure Taif is Mr. Taif postponing his class, or he will carry on. Any idea? Hello, any idea, Mr. Taif? Is my voice lagging? So it seems like a response slow. No idea. So if again, if you want to you have to propose to him. Please don't keep yourself silent. So we all can understand, partly at this period. So we are trying to help, but you don't voice out. You don't voice out, then nobody will know. Okay? So I do my part definitely because I know how many years I've been going through with this kind of process. So I know that students actually at this moment they need to focus. So we also know that even we have class also, your soul is not with the class, it's with the thesis. So it's no point that I keep your body in the class. Okay, so let's move on. So otherwise, if you want the whatever that you need, then please talk to your respective lecturer. So this part, I think I covered already. I just explained to you the sound. This is all the explanation on the moving average filter, which is a special case of the recursive filter, where it's a FIR. However, it's a recursive filter, so it can be a non-recursive as well. So these are two examples over here, where this the one that you see feed forward, always feed forward only. So this is a non-recursive of the relation. of the moving average filter, and then on the other hand, the moving average in terms of FIR, but you have a feedback, which is a recursive way that you do it. So it's a simile. So you may notice that all this one are in terms of FIR, each of the so-called after each of the day, you always do the summation accordingly. But only for the so-called unique of this one recursive moving average filter in this case here, the first one and the last one only they have going to the summation. In between all this one is cancel out. If you follow the equation the sum, the so-called the summation the sum, you cancel out all the terms in between, so it's only one. So you can imagine that let's say your moving average, you have a lot of delays. So this will benefit a lot because you don't need to do a lot of computations. But very unfortunately, you always have an additional delay compared to the FIR, definitely. So why? Because of the calculation. Okay, so this is one of the past questions 2014. Let's see similarly. Something similar to the question I said now. So it's basically I modify the question to become the question just now that you have done. So basically this is something like without the diagram but with the distribution chart. This is now recursive determine in order to reduce the amount memory and processing time, the recursive solution in then this how you multiply this thing become like this. So these are then using recursive you calculate the result of the unit step as well. In order to do comparison, so just here you use the FIR or sorry I should say non-recursive, use the non-recursive to calculate for the unit step response. And then you use a recursive solution, recursive moving average filter to calculate based on the same input to calculate for the output to do a comparison. So since both are the moving average, the answers should be the same. So that's why it should be the same. Okay. So these are some of the answers over here. So you can actually oh. Okay, start to getting lag. So this is check the stability, whatever, so all this stuff will come. So this part will be all the digital IR filter design. So hopefully today actually we shall cover one of the methods. So we just review on one of the method. But although this only focus on the Dsp, but actually involve the designing analog filters. Unless you're given, then probably you need. So these are some process here. So I think the easy one actually is whole based method. So whether you want to design low pass filter, high pass filter. So this how where you place the poles and zero. So these are the knowledge of the poles and zero location in getting the type of filter that you want. Then this is if you talk about second order, so it can give you a luxury to create a band pass filter or band stop filter. I think the key is sometimes you are required to determine a unity gain. So this is for the band stop filter. So see the location of poles and zero. So this is some of the parts here. So I think we will leave it to you to go through. Because it's just about 6, so you can see the complexity of the calculation. And I think you can use a calculator, but the first place that you try to factorize it, so like what you see here, try to factorize in a simple way, then so that you can left only some of the terms on it. So these are the answers here, and then so this is one of the classic questions that pole zero basement method. So you are trying to design a filter in order the signal originate itself already corrupted by a 4 kHz signal. So you want to remove by a filter by using pole zero replacement. Okay, so therefore you try to choose poles and zero to alternate, means that you try to suppress the 4 kHz while minimizing attenuation of the remaining frequencies. So the purpose that you want to do is you want to minimize the filters. After filter, you want to suppress the signal. So you are given a standard frequency of this one is 16 kHz. Then choose the pole zero consequently determine the system transfer function. So what you can do, obviously, all this method I already talked about So let me draw some line. X-axis, real of the Z, then another is y-axis, imaginary of the Z, real of Z, imaginary of the Z, I should say like this. So then after that, where you want to place holes of 0. So basically, first of all, you need to understand that over here, when angle, because in the Z domain, the angle represents the frequency. So therefore, when the angle 0 degree is represent 0 hertz. So when your angle is until 120, 180 degree, it's actually holding frequency. So 180 degree, it represents the frequency. And you turn back to sample frequency, that will give you a sample frequency, which also is a 0 hertz as well. Means that it's a repeated, replicated technology. So therefore, you have this one. So your sample frequency is 16 kilohertz. So therefore, we know that 180 degree is actually equivalent to 8 kilohertz. So you want to suppress 4 kilohertz. So let me use an kilohertz. So you want to suppress 4 kilohertz. You want to suppress 4 kilohertz. So 180 degree is 8 kilohertz. So 4 kilohertz definitely is 90 degree. So you want to suppress it. Suppress means that you want to stop band. You put a 0 over here. Okay, and because of the folding behavior, then you always have replicated another one over here. Means that it's folded here and here folded. So you put this one, after that you put another one, conjugate. So that's how you can actually make this one. So you can actually try to put this one over here in order to terminate problems. Okay, so and as you know that you want to make sure that other frequency remaining frequency are minimizing attenuation. So what you can do is, because you know that you want to create a band stop filter, you just want to suppress this family. So therefore you can to create a band stop filter. So basically you can put a pole somewhere here, and then conjugate pair with here. Okay, so this, but you cannot touch the unit circle, because once the pole touch the unit circle, it becomes marginally stable. So that's why we don't let the pole touching the unit circle, but you always reverse a little bit, get here, so that is radius, let's say normally example is radius 0.95. Sorry, it's not 6, 0.95. Okay, so therefore now based on that basement, so you can know that so you may notice that first of all your zero location is Z equals to A, because the imaginary axis, then another Z equals to minus J. This refer to this zero is Z equals to J, this zero is Z equals to negative J. Then on the other hand, then you may have a pulse is Z equals to radius 0.98, 0.9J, or J 0.9 up to you, which one they use, and another is Z equals to 0.9J. Then once you have this one already, you can form your H step already. Okay, so this is something like if you recall back, you from here you obtain this one, then how you obtain trend, or let's say you have transfer function, you obtain this one, and then you go to this one to identify stability. So this is the reverse process. You already got know this one, then you go back to your poles and zero location. From the poles and your zero location, then you try to form your transfer function. Okay, so 10 marks. So because that 10 marks, once you come out your transfer function idea, probably you need to investigate further, because it's mentioned that you try to minimize the attenuation of the remaining frequency. So now, and when I put a poll like this, yeah, so will it reserve this minimizing explanation or not? So the minimization is until what level? So you might need to do a little bit investigation. So you try to find the frequency. In this case, for kilohertz, say, well, we can find the frequency 3 kilohertz, 3.5 kilohertz, or 4.5 kilohertz. Then, so in such a way that you try to understand that with the poles over here, with the zero over here, so what is the attenuation on the remaining frequencies? The target 4 kilohertz, you also can investigate on the 4 kilohertz. Will you have zero exactly after filter? So these are all the investigation based on the Z value, then substitute into the transfer function in getting the so-called response. So this is some of the answers here and so on. So basically this one blah blah blah, and then this one will be a little bit different with what I explained, because its own way that you put the poles at the origin first of all. But you see over here, this is the one that I mentioned earlier that I put 0.9. Okay. Then from here I can obtain my transfer function in this format. So obviously whatever I mentioned here, although in mathematics, but some of the things that when you put 0.9 whatever, you might want to do some explanation. So these are some explanation that you might need. Okay. So this is an investigation. So when the frequency 4 kilohertz so let's say it's not near to 4 kilohertz, what happened? So you have some of the calculation on the magnetic. Oh, finish. Oh, so good. So this is one of method. So I shall go through with you another 2 more methods. 3 more methods, but anyway, that's all the filter design methods. Any question? So this is one of the suggested way. So you see all the investigation on the frequency. But this is one of way, but the one that I mentioned to you just now, yeah, I start with this one, I explain in the process, then I come out this one, then I come out a transfer function, then after that investigate this really work or not to suppress the 4 kilohertz, and then while minimizing explanation of the remaining. So I need some investigation after this one, after I got the transfer function. So this is the proposed solution. So not to say right or wrong, it's just another way of solving the question. So any question? All in once? Hello? No, good. So no question, probably we can take a break for those that you have done your quiz, but at the end you don't have the chance to submit. I'm sorry, but take a short break. 2:45. So let me resume the class by 3 o'clock. Then I go through with you another few more methods on the digital IR filter design. Okay, thank you very much. I shall see you later. So let me take my attendance now. Yes, Gun, what's your testing about? Test your voice. You want to sing? So any question that you wish to ask before I move on to our review? This should be our last review. After that, you need to do your own work. But I think we have another one in MATLAB session, so we'll see what we can do then. But I think just on the theories or the calculation, whatever that actually is, I think I have covered already. Okay? So I need you to do your part as well. Yeah, although I know that your focus is with the thesis. Okay, so anyone got any question before I move on with the rest of the topics here? I would suggest you that your final project is better that you do a pre-recording for yourself, whatever that you try to demonstrate, things like that. So it's better that you keep a copy of the records, case anything that you ask. Not to say that it's a must, just a protection, okay? Safety precautions. Then as well as don't forget to back up whatever the information, the materials that you have, just in case that you need to have. Yeah, if you insist that you want to have that, no problem. But I just try to, what I try to demonstrate is you have to read the instruction. Whether that instruction is fair or not is another story. So you want to argue on that, I have no problem to argue on that. No, yeah, you can have tons of time to read and tons of time to do a submission. But that's what I try to demonstrate is do you read the instruction? So, okay. I don't think it's a 10 minutes of reading. Normally it should be 5 minutes of reading only, but I think it's very subjective to individual college as well. So if I happen to go through the USM one, USM actually they have a 5 minutes of reading only. Okay. Then whether 45 minutes, whether it's not, then that very subjective to individual of the structure question being set. And I will have to tell you also that you should have less time in solving the question just now, because another question is about the filter design. Then filter design, you need to spend more time. So how much time that is very subjective to you, to your way of doing it. Okay. So 10 minutes of submission or not, then let's say physical exam, normally you don't it's just a matter of waiting for the collection of the answer booklet. But let's say for those, the one that in the online exam, yeah, we actually allocate 15 minutes instead of 10 minutes for the submission. But again, like I said, this is whatever we practice on the road, what's not on Northumbria. Northumbria, you have their own setting. So whether that setting is fair or not, I think that definitely, I think Dr. Sim will be helping us to do that classification. We all follow whatever that we are practicing here. So yeah, I think I have one. I think let me find because yesterday I introduced actually Dr. Sim also introduced something. Wait, let me find. Dr. Sim actually introduced this one apps. Let's say it's online, then it introduce an app actually will give you a one-stop center, one-stop PDF creation. So whatever you do now, you might need to snapshot and then save in the Word file and then save as PDF file in order to do uploading. So these apps here, it will allow you to actually enable you to do take a step. When you take a snapshot, then indirectly you actually you can do the forget the PDF without doing so let me find his message again. Yeah, I think I used that before years ago. I think at least 4 years ago. I don't use it because my handphone storage full already, so I need to uninstall some of the things. Where's his message? You can find in Google Play Cam Scanner. Yeah, Cam Scanner. Let me copy this one. Yes. But again, that depends on whether we have a online exam or not. Whether then that depends. Again, all those rules and regulation or the instruction. It will be announced probably later. Not with me. I don't know. Okay, but it could be one of the solutions that would be give you a shorter duration of the time, shorter duration in preparing the submission file. Okay, then I think regardless of the apps about, so it's most important that when you snapshot your answers, the lighting environment. Because if your image quality is not good, then whatever the software you use, it won't be helping you a lot. It just enhance a little bit here and there, which I think that Jia Hong probably he can share with you more on it. Hello, Jia Hong. Yeah, so if your image quality no good, so no matter how you do, it's still this. It's still the problem. Will still be the same thing. It won't solve the problem. It create more problem for you. Okay, so David, am I answering your question? So again, read the instruction. Don't just rely on your assumption. So you have to be careful. Okay, so it's just like conventionally we think now, but now let's say going to online, it could be a different practice. So you have to be cautious with all the changes that may happen. So let me go through with you this last round. So basically you have a left and this one. So because structure and duration basically is nothing much, it's all based on whatever that you have practiced over here. Then you try to identify whether it's a so-called canonic form or whether it's a direct form or how you want to realize it. Okay. So for NZT basically is solely this formula. So this all those formula may not be given. But going to online probably can search for yourself. But anyway, then it's just a direct substitution. So regardless of the poles or zero in the analog transfer function in the S, then you just substitute based on this formula, you just substitute accordingly. Then you can further process mathematically in order to form your transfer function. So MZT and the impulse gradient, they are a little bit alike. The poles definitely they have the same one. This is the example. The poles definitely are the same. This direct mapping means that your analog, whatever your analog poles or zero, you direct map by using this formula, direct map to get your so-called your digital poles and zero. But this one will go through some process in order to do this one. The difference actually is impulse invariant, your transfer function normally will produce give you a sum of the sum sub-function. And direct mapping, let's say originally normally you put in product form, multiply, or defactorize with the multiplication. Then you just directly sub mapping. And after that, you open a bracket to obtain your transfer function. Then this one is because you involve a partial fraction expansion normally. So therefore, your transfer function normally is in terms of the summation of the two functions. Then after that, you have to combine it expand it in order to obtain your final answer of the transfer function. That process actually create the differences. The poles are the same, the differences actually is the zeros. The difference of the zero will give you a shape of the frequency response differently, whether it's a ripples or sharper or whatever, then it's all give you a different kind of the response. But generally, it's the type of the filter is still about the same. Okay, so there's a difference between these two methods, and I think we have done this before during our class. But let's say you are given the digital codes here, so it asks you to show, then you can show this one, but actually no marks. This is a mistake, I think, for that paper. It doesn't give any marks, so you show or not show also no marks. So anyway, you based on this one, then you try to prove some of the stuff over here. So the rest actually you can see that it's something like what I call as fundamentals for you to prove it. Okay, then this one's our answers. That's why you see the slide so many. One of the reasons because of the answers and so many answers. Yeah, let's see this one. Why this one need to do this one also? You have to let's read this one. Okay, where's the relation using the Paul function that you can do? We need number 4. 2, 3, 4. The B. I think I didn't show the B question. B question actually asks you to do something on the canonic periodization. So you have to show this one. And then this is in one of the example so-called the impulse invariant method. And normally in impulse invariant method is the main thing is factorization. You should have, normally you are given the analog transfer function first of all, then the rest of it factorize this one, factorize this one. So therefore you can obtain your so-called your factors. Then you can do the partial fraction expansion. So therefore this is also example over here. So this one is just about the beginning one, but this is a part that actually this one. So you see this one. So this is another method that you can use is the completing square method, where you give you a pair that and you can find from the table. So it's therefore this completing square method, it could be one of method that you can make use of that. But bear in mind, this must be a plus. If it's a minus sign, you can use it because referring table it must be a plus. If it's a minus sign, then sorry, you cannot use this pair. You have to go back to another pair for the answer to get the answer. Okay, so then on the other hand, from the BZT method, this will be heavily on the starting until the ending. Means that starting design analog filter followed by the transformation in order to obtain the digital filter. So these are the few steps over here. And mainly this one is all about formulas. So you have the formulas, and then formulas, and then another formulas. These are all the formulas to hook up to this one. So in general, you have an analog filter. You try to use this formula to get your, you have the digital filter spec. Then you try to use this formula to form your analog filter spec. So after that, you try to do some processing, whether to obtain the filter order, whatever. Then you try to do is make use of the low pass prototype method here in order to do the design of the analog filter. So once you got the analog transfer function, once you obtain the analog transfer function, then you use this formula to get your digital transfer function. So these are the 3 steps involving okay, so that's something that to show that based on this one, to show this one. So these are the mathematical derivation. Then this one will be the theory behind that, principle behind the use of the BZT. Okay, so I leave it to you to read. This one will be the proving part. Then another one will be explain the design process. Means that you want to design a digital filter design of the low pass filter using BZT method. So these are the steps that to describe the step. That's how I mentioned three steps in. Then you can actually describe the process, how you obtain the answers at the end. So this is another one, frequency warping. So the theory about frequency warping. Okay, then this is also another theory. What are the steps? So these are the steps. 3 steps. This one. These are a lot of explanation. So this because 6 marks, you might want to explain a little bit details the theory. Okay. Then this is the one that I will also is you are actually directly given analog trend function instead of designing the so-called filter that from the beginning, but instead you are given a normalized analog trend function. So this is a low pass filter because normalized. So normalized always talk about low pass filter. So therefore this is a low pass filter actually. But our digital filter is required to have the above frequency behavior, means that low pass filter, based upon 2.5 kilohertz. Means that based on this one, I want to base on the 2.5 kilohertz instead of the 1 radian per second color frequency. Now I want to base on the 2.5 kilohertz. But bear in mind, this is digital filter. So therefore, with the sampling frequency given 8 kilohertz design. So you have to remember the step first. So probably I overwrite on here. So normally, first of all, normally we have a digital filter spec. So I need to convert to analog filter spec. So how we convert the tangent? So now you read this question. May I know what is my digital filter spec? Yes, Jia Hong. May I know what is my digital filter spec in this question? Hey, hello, Jia Hong. Are you there? Sleeping already? Probably I ask another one. John, you owe me. I think you need me to help you something. So now you need to help me something before that. So John, yeah, low pass question mark. So from this question, may I know what is my digital filter spec? When I say digital filter spec, what are the information that we need to know? So in general, we talk about four information. FS FC. Wow, FS is what? FC. Yeah, sampling frequency. So do I know sampling frequency in this question? Okay. So general, whenever you talk about filter spec, regardless of analog digital, so normally you talk about I'm sorry, I got Parkinson already, so I don't see it's a good drawing now. Okay, so normally we talk about ripple, ripple, isn't it? So on the y-axis, we talk about pass band ripple and stop band ripple, so the value over here. And then on the x-axis, we talk about the cutoff frequency, pass band cutoff frequency, and stop band cutoff frequency. So from this question, what information that we have is 2.5 kilohertz. So this based upon above frequency behavior low pass filter, based upon this is 1 radian, based upon is a 2.5 kilohertz. So that means that the cutoff frequency of this digital low pass filter is 2.5 kilohertz. Okay, then it's a low pass filter. Yes, you're right, because based upon the frequency behavior, the low pass filter, and then followed by the ripples. Is it necessary to know? It's not given also. So that's why it's not necessarily one of the reasons that is it already fixed the prototype transfer function is normalized. This one is already give you. So therefore, whatever the ripple concern, you concern it's already done. It's already. So that's why this ripple, how many is not this one. And do you need the stop back color frequency or not? So it's not given as well. But with this one, because second orders, so I think they mentioned Butterworth Chebyshev or the other laser. So you can actually roughly you can tell that second order is that the roll off here is 20 dB per decade. But we don't know exactly. But it's also not our concern also if not given whether the stop and cut frequency need to be known. Okay, but another information important like John mentioned, the sampling frequency 8 kHz. So may I know what's the maximum frequency here? What is my maximum frequency? Yeah, 4K. So this is 2.5K. And sorry, I don't have space already. So this is 2.5K. And this is 4K. Okay. So with that, then can you obtain? So now this is my digital filter spec. So if you follow the method exactly just now, first of all, digital filter spec, I need to convert analog filter. I only know one color frequency. So therefore, I just convert this color frequency into the analog filter spec by using what formula that we need to use. Yes. Yin Kai. So what formula we need to use? Let's say this my digital filter having a cutoff frequency of 2.5K. So what should I use? What formula I need to use to convert this to analog filter spec? Oh, oops. Yin Kai. Yes, what formula? Just now got three formulas there, isn't it? So basically, the main one got two is the one is the tangent, and now is the S equals to Z minus 1 over plus 1. So basically, we use a tangent formula to convert. So which is this one? This one. So let me, this one. I think show you the step this one. So this one, this is the one frequency warping where you use this formula to convert. So means that your digital frequency, the sound color frequency is 2.5 kilo, 2 pi multiplied 2.5 kilo multiplied with sampling interval. In this case, it's a 1 over 8 kilo divided by 2 tangent, and then you got in your analog color frequency. So once you know your analog color frequency, let's say you know your analog color frequency in terms of analog filter spec. So I can move to my second step already. What the second step is, I can try to come out my HS analog trend function, and based on the PS, which is actually is a normalized trend function, which is low pass filter, by substituting omega. I don't have omega. I use W equals to. So what should I do? There's a substitution. We need to substitute something. So what's the substitution? So we go back to the step just now. So remember the series of formula, low pass to low pass, high pass to high pass, low pass to high pass, things like that. See? So let this in this case low pass to low pass. Originally it's low pass filter. Now we use a low pass filter type, so therefore it's a low pass to low pass. So it's a sorry, not here yet. I think there's one more step. You need to normalize first. Where is it? Oh, it's not in this slide here. But anyway, the step number 2 actually is not about this one. Yes. You obtain this one by using the low pass to low pass S over omega C, which is the one that low pass is now. Same thing. Not this one. Hey, missing also. Low pass, this one, low pass S over omega C. So your omega C basically will be your calculation of the tangent is not obtained. So in such a way that you can actually get your substitute into here. S over omega C, S over omega C, S over omega C accordingly. Then you get your analog trend function. So once you got this one analog trend function, then you can go to step number 3. So do I need to find the filter order? No need, is it? Because you already given. So you will look back to the method that we use to find the filter order. That because we don't know this one. Ultimately, we try to find a button filter, we try to refer table based on filter order to refer table. We try to find this thing only. But let's say a given only, no need to find filter order. You can actually sum the step. And the last step is a hitch step. So by using s equals to z minus 1 over z plus 1. Okay, so is therefore you have these 3 steps there. Then you can obtain your line Hausstring function. Okay, then the next one actually is based on whatever you have, you try to obtain your canonic form, but in a signal flow diagram with the minimum delay sections. So these are some of the segments. So this one does nothing much. We try to demonstrate to you the bus splitter prototype. It looks like that. But this one, first of all, whatever my digital filter, I convert 2pi multiplied 2.5k divided by 8k multiplied by 2, so therefore it's a 16. The kk cancel already, so therefore you have omega a equals to 1. Then because low pass, s omega c, s omega c, s omega c, s omega c square based on this one. Based on this one. S omega c, S omega c, S omega c. So omega c obtained from the first step. So then you obtain this one. So once you obtain this one, step number 3, S equals to Z minus 1 over Z plus 1, substitute in accordingly. Then the rest of it mathematically. Then you got this one. So I would say that this is actually not a correct transfer function because you still have this. This should be 1. This make it 1. Always make it 1. So this 1, it will be how to do it? Your denominator divided by 7.75, numerator also divided by 7.75. Then you can get your Hausstring function. Then this part is so this is the part of this one. You're splitting it in order to give your canonic form, but in the signal flow graph way. This not, but I think signal flow actually there are a lot of people actually they practice it. Different group also mentioned differently. So you can follow with the slide that we have to have a signal flow graph. So normally signal flow graph we don't have all those symbols, but it's subjective to individual. So that's why I would argue that which one is right or wrong. As long as you have that structure, the meaning for us is structure. Make sure you have the structure, then you can implement. So this one will be a little bit calculation behind that to obtain the form of this one. Okay, so that's the one that a little bit unique. That question a bit unique because you are given some information upfront, then you try to process based on what you have. Okay, then the rest of it, then these are some criteria to design filter, to draw the relation filter. Then this one, theory, flowing, and then the step of the design. So this is make it 1. So this, I think this is the, I think my handwriting last time still the same like now, or probably now it's more ugly because of the Parkinson. Okay, so and these are some more theories. So back this is about 9 years ago already. So anyway, the theory won't change because of that for years. Okay, so otherwise I think I need to leave it to you to try on. So this typically this is some of the one of the questions that traditionally you are given the digital filter response, frequency response like this. Then you try to design based on the BZT method. So these are all the things that 1, 2, 3, 4. You need to do is you need to convert to analog first of all. after convert analog, you need to normalize it or low pass prototype it, things like that. So these are the long activities. So that's why normally the marks is very high for particular kind of question that you start from the beginning. If you compare with just now. Okay, so these are all the steps. So you do this one. Then you all your I think you can skip this one. You can directly jump to here. Then you can obtain your analog frequency. This is the formula to convert digital frequency to analog frequency. So once you got analog frequency for band pass or band stop filter, it requires to find a center frequency and a bandwidth because you need to normalize whatever the frequency value here. You try to normalize by using the formula. So therefore, you may see that I can guarantee you your answer, you have a positive one and a negative one. This is very close, one of the reason decimal points, but it will be 1 and negative 1. So it means that your pass band color frequency 1 and negative 1. Then the rest, the other two will be stop and cut off frequency. What value is it? It's subjective to it's a normalization, so subjective to how far away they get. So therefore you have this value and this value differently. Then I think filter order, because you are not given any kind of normalized trend function, so you need to decide. So you need to find the filter order. So you can find both sides for the filter order, but you can choose to be shuffled or off to decide to find that particular filter order enough to determine the filter order. Then once the second order referring to particular table, then you get this one, and then you try to denormalize it by using another formula, substitute in, and it will be very complicated because it has power. Then the rest you substitute in to them. But I think this is the last time we did it like this. But like I say, I actually kind of recommend that try not to split, open up the bracket, or try not to put the value inside. Because once you put the value inside, the value will give you a crazy kind of the value of the decimals for you to deal with. So probably it's good that you don't substitute value in before you process until the last step. But again, complexity is there because second order will give you a fourth order of the band pass and band stop filter. Okay? So therefore, so now if I do a reverse engineering, so now let's say you know your band pass or band stop filter is order of 4. So this answer is 2. So if you look at some partial questions, actually they kind of like one of the tricks that is you may be misled because of this. So low pass, high pass, this second order will give you answer, final answer second order also. But only for band pass and band stop. Your answer over here second order. But however, your final answer actually is a fourth order. So make it a little bit simpler, so you can imagine that over here I need a second order, over here I need a second order. So second order plus another second order is fourth order. So total is fourth order. So therefore, your band pass or band stop actually will be fourth order instead of the answer calculation of the filter order is second order. Okay, so these are the sum of the given answer in the solutions. I think I won't repeat that. So these are some scenarios here. So I think you need to do your own part. Okay, so this is this is also similar like the star one, but just more complicated. So this is also you are given this actually asks you to prove that this format. Okay, so how I prove it? So similarly the step won't change. It's just that what are the part of the step you no need to do, you can skip. So let's look at this one. Desire to get a digital low pass filter, that's a particular characteristic. The desired filter to have a negative 3 dB color frequency 1 kHz and attenuation 20 dB at 2 kHz with sampling frequency of 8 kHz. So let's try to do this one. So probably you can spend a little time to do this one. Okay, so we jot down the information here. Probably I draw first. So let's try to do this one. Sometimes this is quite interesting because it's your given, ask you to prove. So you have to be careful. Sometimes your value and this value may not be exactly the same. The reason obviously very straightforward, like decimal points. Depends on how you, I don't know this guy during the derivation process, how many decimal points he used. It looks like 3 decimal, but for 4 decimal some more. So I have no idea at all. But that's why don't worry about that. Whatever that you have, you try to do. Then when you compare, you try to compare at the approximate level. For example, maybe you got 0.4149. Then I think should be fine because of the decimals. So let's try to do so that you can, first of all, you need to imagine that this is a low pass filter, so you always try to draw. Your drawing may not have marks, depends on the question, but anyway, drawing will give you a better idea of what you have here. This is 1 kilohertz. Okay, then this is negative 3, minus 3 dB. So it means that we are talking about unity gain of the filter. Then attenuation of 20 dB at 2 kHz. So this is 2 kHz. So this one is 2 kHz. Then over here, minus 20 dB. It says minus 20 dB. So this is negative 20. So this is 1 kilo, this is 2 kilo. And then over here, digital filter always for maximum frequency. What's my central frequency in this case? 8 kilo. So therefore here 4 kilo. Okay, so now we can imagine that, oh yeah, first step, I need to convert these two values into the analog by using the tangent. So can you try to do some calculation? Convert this 1K and 2K into the analog by using the tangent formula. Okay, I assume you are doing as usual. I cannot see what you are doing there, whether you are not listening or not listening. So that's why online learning is all about the initiative, whether you want to learn or not. It's not about me push you to learn. It's about you want to learn or not. Wow, so soon. So stressed. So fast need to submit report. Okay, so what's the answer? For the so-called the pass band cutoff frequency, after you tangent, what's the value that you have? I think it should be in the form of omega rather than f, isn't it? Because the formula actually talk about omega. So that your so your passband cutoff frequency, let's say your digital is 1 kilohertz. So your passband cutoff frequency after you convert to analog, your passband I call P. Passband omega P is with 0.4142. So again, using gradient, so be careful. Then your stop band cutoff frequency after you use a tangent to do, or surprisingly, is equals to 1. Yeah. So this will be your tangent formula. And then you use it to find your digital frequency is a 1 kilohertz. Then convert to analog, become a 0.4142. For the 2 kilohertz, you convert it will give you 1. So that's the something that actually you can do. And then so normally when you until here, normally we'll do a normalizations. Okay? But only for low pass filter, you no need to do normalization. You can directly use a formula to calculate to get your answer in terms of filter order 3. Okay? So that's why not surprisingly it filter out the 3, because if you look at this format here, so basically it should give you a so-called the filter order of 3 already. So if I show you the Butterworth polynomial table, just hang on. So it's all these polynomial table, they are standard. So regardless of where you find it, it's the same one. It's standardized already. So let me I give you a link, an image link. Image file. Where is my image link? Call me image. Oh, this is bad. Because give me something. Save image. So are you still with me, or you are actually don't know where you are already? So if your calculation shows that the filter order is 3, then you can refer to the table here. So which means that your low pass prototype transfer function HS based on the filter order you found is 3, then you can based on that to tell that your low pass prototype LPP is still LPP because it's a 1 radian per second for the color frequency. So it's this one at the denominator. Okay, so that's why filter order 3 leads you to the table to find your denominator of the polynomial. Then you put it like this 1 over whatever that you have over here. So from here, then what's the next one? Because this function is a color frequency 1 radian per second. So you need to denormalize it by using S equals to S over omega C. Okay, is it raining? S over S omega C. Okay, S over S omega C. Then substitute to here. What's the omega C? So very beginning the sum you found already, 0.142. So therefore, you just substitute in accordingly only. So you just substitute in accordingly only. So this one, we got this one here. Then you just substitute S over 0.4142 into this equation. Then it will give you this one. Okay. So once you got this one is a analog transfer function for the analog filter. Then the next step is just a substitution of this one into the analog transfer function. Then blah 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 blah. Then at the end it will produce this one. So that's why when you see, be careful with this one, because this is an example that I want to tell. So if you see this is a two portion, two factors, don't open the bracket. Leave it so until the end. Okay? So means that this portion belongs to this part. This one belongs to this one. This one belongs to this one. And how about this one and this one? This is very subjective already. So you have to rely on your observation on the financial numerator here in order to decide how you want to deal with this guy in order to split to two parts like this. So basically this one multiply this one, it will give you this one actually. Okay. So therefore you have to decide that how you want to split this one to two. Okay, so that's the numerator that you have to play around a little bit tricks in order to obtain this one, the answer. Okay. So only the denominator one that you don't do anything, just factor multiply factors and factors don't multiply. Just a dv factors factor, you give you these two factors accordingly. Then numerator one you have to process otherwise. So you have to be smart in linking to the original one. Okay, those at least are you can show until over here 12 marks. Yeah, not an easy job. Yes, 12 marks. Then the rest of it based on this one, can you calculate the DC gain? Can you calculate the 4 kilohertz gain? Then frequency 4 kilohertz. Then just substitute accordingly. Okay, so this one there. So when DC, I think last time we had gone through one now. When DC z equals to 1. When 4 kilohertz reach the folding frequency, so therefore it's pi, so pi is z equal to -1. Then you substitute z equals to 1, z equal to -1 into here, then it gives you the result of 1 and 0 because it's a fast filter. Frequency is 0 hertz, gain is 1. Frequency and the folding frequency is the folding frequency, so your gain is 0. So that will give you the answer of the low pass filter. Okay, so I think there's the part about the realization. I think the question not here. There's a part, I think another part is not about realization. It's not included in the question here. So that's why the answer about the realization part. Then this one. The channel plan is shown to be a 2 sections. So 2 section means that you have 1 section, 2 section. So you realize it into you realize this one connecting in series to another one, cascade, actually cascade 2 sections. That will give you this one, the section 1, section 2. Okay, connecting in series because here is Y1N output, this Y1N output connecting to this one, Y2N. Okay. Then the benefit actually is reducing the accumulation of rounding errors because if you have very long of the you have a long series of the so-called your delays, comparing to this one is separating the into cascade way, then this will give you a better rounding errors control. You have the reduction of the accumulation of the why accumulation, because there's always a feedback. The feedback actually will give you that feedback always give you the things that accumulate the error. Okay, so that I think that's all. Finished already. So any question on the question just now? So this is another typical way that the BZP question it can be asked differently. But you have to understand the overall picture of BZP design method before you talk about this question is starting from where, or you need to have this information, or you don't need to have that information in the calculation side. Okay, so any questions? My side is raining only. How about your side? So I think the raining is a more interesting topic than DSP. Calling once? Still no response as usual. So gun. So Alostar faster. Is Alostar raining gun? Oh no, I think Alostar too far away from us. I think gun need to wait 1 hour later only he'll receive. Punyao? Yeah, so can you get no, I don't want to ask about raining, sorry. You are in Penang Island only, so I don't care. So I care that whether you understand whatever I try to explain just now or not. If you don't understand, you can refer back to the video later, but that video is only valid for 2 weeks only. Yeah, yeah, I know. That's why the review actually is more on you need to do your own homework first before you come to the review. It's not to let me talk again until I finish all my story. Am I? You try to understand it, but I think others actually almost all of you actually try to focus on thesis and but anyway, you make sure that this one too complicated on formula. It's not the flow lah. I think the main thing is the flow. Overall picture that how this formula from formula to one formula to another formula to use it. So you must have that big picture in mind so that you won't get lost. Then after that you just make sure that you can follow one by one. Whether sometimes you got this information, sometimes you don't have this information, so you have to be clear about the information that you have in hand. Then you need to judge. That's why the question, do more question to help you to make a better judgment. Then whether you don't need to do this one, you can jump to here, you can jump to there. Okay? You need to have that mindset before you want to solve a question. Okay, so Kogil, are you okay? Yeah. Okay, so I think like I say next week actually we don't have a class. We'll postpone our class. Then after that, I think on the 6th, let me see the timetable. 6th of May we'll have our usual class. But let's say we happen to know our exam timetable earlier, then I will do my replacement earlier as well. So please get prepared. So I think I still got one more class with you on the lecture. Then another one class actually is for the MATLAB sessions. So I let you know that whether next week I'll do the MATLAB workshop on my own with the free recording or not. But I believe that you should focus on the thesis first round. And on the other hand, I think a lot of the things that are pending because we don't have enough information to do the decision yet. So we have to wait for decision. Like I'm not sure this Friday our Prime Minister will announce MCO expansion or not. So we'll see. Okay. So but I believe that even it's limited, also it's a limited, restricted activities. So but the main thing I think is to make our economy recover. So because after about 1 month of without any activities, the cash flow is not enough. So therefore, there's all the restrictions on the activity, but still make sure that business as usual. Similarly, like KDU, so I believe we are planning a final exam on the 28th or 29th of April. No, sorry. It's early of May, first week of May. I should say second week May. 4th of May, we start to have exam for those that do awards. Okay, that's the planning. So again, that's subjected to whatever the MCO announcement. With I think with the cases, 0 cases for how many days? 8 days already in Penang. Touch wood, hopefully today also zero case. Then we are actually moving to the green zone. Once we are in the green zone, then that restriction may not be so strict already. Then I believe that you can go to KDU, but just at social distance. Need to maintain. Okay. So like I say, I finished out everything already. So I think it's now I leave it to you whether tons of the final exam questions over there in the canvas there for you to try on. Make sure that you practice. Make sure that you try to control the time that you have. So that to solve a question, certain question you may not necessarily to demonstrate a full step. Means that you don't need to show 1 plus 1 equals to 2, 2 plus 1 equals to 3, 3 plus 1 no need. Not necessary. So answer working solutions is just a working solution. It doesn't demonstrate to you need to do how fast So it just tell you the answers like this. It also never, it doesn't tell you the way that you should do is exactly follow the solution. No, doesn't demonstrate that, but that solutions is for me, lecturers, to understand, to read, and to judge how to give mark. It doesn't tell you, it's telling me. Okay, so with that, anything that I'll keep in touch with you through our agent Billy. So that I'm not sure our Billy still around or not. Oh, it's not in the group already, so he left already. I think probably boycott the class already. So never mind, we boycott him. Probably I'll find my new agent called John. Probably John can be our new agent. So Agent John, are you ready to take over Agent Billy's job? Oh, well, I think John don't want to take note of anything that I mentioned just now. So don't worry, I got a way to find him. So it's 4 o'clock already. So any questions? So now I announce that I finish up all the whatever review I have with you. So then the rest now leave it to you to try on. If you got any question, you can always come back to me as usual. So you can always post or whatever, ask question, then no problem for that. But the key is whether you ready or not. So I know this is important. So good luck in your thesis writing. Make sure you submit on time. Don't create a delay. And also always back up whatever that you have. Don't torture your laptop until it crash already. You start to try. You don't back up. So back up now. So also, as I suggested, so probably you can do a pre-recording on whatever the things that you have, whether your demonstration, whatever, so that at least it's as evidence to demonstrate to others that you got the project done already. So, any question? Hello, calling once. Toot, toot, toot. Chanming, any question? Jingkang, any question? Chunhong, any question? Okay. There. So remember Agent John. See, this is a new agent, Agent John. So I will tell John what will come out in exam. So please refer to him anytime from now. What will come out in the exam. So please. So I won't tell you, but I tell him only. Okay. Thank you very much and good luck in the thesis writing. So bye.